Definition of an empty set. So welcome to this tutorial on the empty set. As we begin, let's set the stage. We're diving into a really interesting area of mathematics called set theory. Now, set theory is basically the study of collections of things. We call these collection sets. Within set theory, we deal with many different kinds of sets, and today we're going to focus on a particularly important one, the empty set. Now, the empty set might seem a little strange at first. It's a fundamental concept, meaning it's a core building block for more advanced ideas, but it can be a bit confusing when you first encounter it. Don't worry if it doesn't immediately click, that's perfectly normal. Over the course of this tutorial, we'll break down exactly what the empty set is, why it's important, and how it's different from the sets you're probably already familiar with. We'll use examples to make sure you get a solid understanding. We'll start by quickly reminding ourselves what a set even is before we jump into the specifics of the empty set. So, let's get started. What is a set? A quick recap. So we've just started talking about something called the empty set, which might sound a little strange at first. But before we jump into what an empty set is, let's make sure we're all on the same page about what a set actually is. It's a quick recap, but a really important one. A set is simply a well-defined collection of distinct objects, and we treat this collection as a single object itself. Think of it like gathering a bunch of things together and then considering the whole group as one unit. Now, the individual things within the set, the items we've collected, are called the elements or members of the set. Both terms are used interchangeably, so don't worry about which one to use. We usually use capital letters to name sets. For example, we might call one set A, another B, and another C. And to show what's inside the set, we enclose all the elements within curly braces. So, the curly braces are like the container that holds everything together. Let me give you a couple of examples. If we have a set A, and inside it we put 1, 2, and 3, written as 1, 2, 3 within the curly braces, that means set A contains the numbers 1, 2, and 3. Voiceover. And similarly, if we have a set B, and inside it we put the words apple, banana, and orange, that means set B contains those 3 fruits. See how easy it is? We're just grouping things together and giving the group a name. Voiceover. This understanding of what a set is will be crucial as we move forward to understand what an empty set is, because an empty set is still a set, it just happens to have nothing inside it. So, keep this in mind as we continue. Defining the empty set. So let's move on to formally defining what an empty set is. As we discussed earlier, a set is just a collection of things. Now, an empty set is a set that contains absolutely nothing. That means it has no elements inside it. We can also say it has a size of 0. There are 0 items within the set. Now, to help you visualize this, imagine you have a container, like a box or a bag. An empty set is like that container when it's completely empty. The container exists, it's still there, but it doesn't hold anything inside. Now let's get a little more formal. Mathematicians like to express things precisely. So we say that an empty set, which we'll call set A for now, has a property. This property states that for all possible things, let's call one of those things X. X is not a member of set A. Let me break that down. The symbol for all is represented by an upside-down A, and we say it as for all. So, we read this as for all X. X is not an element of A. The symbol that means is not an element of looks like a capital A with a line through it. We write this formally as, for all X, X is not an element of A. This simply means that no matter what you pick, no matter what X represents, it will never be found inside set A. This might seem a bit abstract now, but it's a really important definition. In the next slide, we'll look at some examples to make it even clearer, and you'll see how this concept applies to real-world scenarios. We'll also see why this seemingly simple idea is actually quite powerful in mathematics. Why is the empty set important? So we've established what an empty set is, a set with absolutely nothing inside it. Now, you might be thinking, if it's empty, what's the point? That's a fair question. This slide explains why the empty set is actually incredibly important in mathematics. First, we have completeness. The empty set ensures the completeness of set theory. Now, what does that mean? Well, imagine trying to build something without all the necessary pieces. Certain mathematical operations and definitions simply wouldn't work correctly if we didn't have the empty set to fill in gaps, so to speak. It allows us to have a fully functioning system. Next, it acts as a foundation for other sets. Think of it like this. The empty set is a basic building block. We can use it to create and define more complex sets and to perform operations on those sets. It's the starting point for a lot of set theory work. Then there's logical consistency. This is about making sure our mathematical arguments make sense. The empty set helps us maintain that logical consistency. If we didn't have it, we could run into paradoxes or contradictions in our reasoning. Finally, it's useful for defining boundaries. In many mathematical concepts, we need to establish limits or boundaries. The empty set can help us do that. It allows us to clearly define where something doesn't exist or apply, which is just as important as defining where it does. We'll see these ideas come to life in the examples on the next slide, so you'll get a better feel for how the empty set is actually used in practice. But for now, it's important to understand that even though it's empty, it's far from useless. It's a fundamental concept that underpins a lot of mathematical thinking. Examples to illustrate the empty set. Let's move on to some examples to really make sure we understand the empty set. As we discussed earlier, the empty set is a set with absolutely nothing inside it. So, let's see how we can identify these sets in practice. Example 1. Consider the set of all even prime numbers greater than 2. Now, remember what prime numbers are. They're numbers greater than 1 that are only divisible by 1 and themselves. And even numbers, as you know, are divisible by 2. So, if we think about it, the only even prime number is 2 itself. The question asks for even prime numbers greater than 2. Since there aren't any numbers that fit that description, the set containing all such numbers is empty. We can represent this set as either an empty set using curly braces, which looks like this, nothing inside, or using a special symbol called the null set, which is a slashed circle. So, we write this set, which we're calling A, as either curly braces with nothing inside, or as the null set symbol. Example 2, let's move on. Consider the set of all months with 32 days. Now think about the calendar. How many months have 32 days? That's right, none. We all know that no month has 32 days. Therefore, the set of all months with 32 days is also an empty set. We can represent this set, which we're calling B, in the same way as before, either with empty curly braces or with the null set symbol. Example 3, finally, let's make it a bit more relatable. Consider the set of all students in your class who are taller than 3 meters. Now, 3 meters is quite tall, that's almost 10 feet. Assuming that no one in your class is taller than 3 meters, this set is empty. We represent this set, which we're calling C, again with either empty curly braces or the null set symbol. So, in each of these examples, we identified a specific criteria and then determined that no objects meet that criteria. That's how we find an empty set. Remember, it's not a set of nothing, it's a set that has nothing in it. This is an important distinction. We'll recap all of this on the next slide and also address some common mistakes students make when dealing with empty sets. Key takeaways. Let's recap everything we've learned about the empty set with these key takeaways. Next, we have the notation. We can represent an empty set in 2 ways. We use either an empty set of curly braces, which looks like this, just 2 curly braces right next to each other with nothing inside, or we use a special symbol, a slashed 0, often called the null symbol. So it looks like a 0 with a line through it. Both of these notations mean exactly the same thing, a set with no elements. Now, why is this seemingly simple concept so important? The empty set is a fundamental concept in set theory. It's not just some weird edge case, it's a building block for a lot of more complex mathematical ideas and reasoning. It allows things to work consistently within the rules of set theory. Finally, identifying an empty set comes down to this. You're looking for collections where no elements meet the conditions you've set. Think back to our examples, the even prime numbers greater than 2 or months with 32 days. In both cases, we were looking for things that simply didn't exist, leading us to an empty set. Keep these points in mind, and you'll have a solid understanding of the empty set. In the next slide, we'll address some common mistakes students make when dealing with this concept, so we can make sure you avoid those pitfalls. Common mistakes. A common mistake is confusing the empty set with a set containing 0 as an element. The set represented as a curly brace with 0 inside, that is, 0, is not an empty set. Remember, the empty set has absolutely nothing inside it. This set, containing just the number 0, does have one element. It's a set with a single member, so it's definitely not empty. It's crucial to really internalize this. The empty set contains no elements at all. It's not a set with 0 in it, it's a set with nothing in it. Think of it as an empty container. The container exists, but it's completely vacant. Finally, another mistake students sometimes make is thinking that an empty set doesn't actually exist. This is incorrect. The empty set is a valid set. It's a perfectly legitimate mathematical object, even though it doesn't contain any members. It's a foundational concept in set theory, as we discussed earlier, and it's essential for the logical consistency of many mathematical ideas. Let's move on to the final slide, where we address some common pitfalls students encounter when working with the empty set. So, to recap, don't confuse the empty set with a set containing 0, and remember that the empty set absolutely exists, even if it's, well, empty. That concludes our tutorial on the empty set. I hope this has given you a solid understanding of this important concept.